Okay. The table below summarizes results from a study of people who refused to answer survey questions. The market researcher is interested in responses, especially from those of age 22 to 29. What's the probability a selected respondent is between ages 22 and 39? So it says, okay, either the selected subject responds or is between 22 and 39, right? So let's go to Excel. By the way, the question's been asked to me a couple times in the last few days. Will we be able to use Excel on the test? Yes. So it's, yeah, I'm wanting you to learn to use Excel for this stuff. So, okay, apparently that's right in the wrong place. There we go. Okay, it says we want everybody who either responded or is between 22 and 59, right? So that's not too bad. All we need to do, we need to find how many people responded. So sum of all these people that responded, right? And we also want, so that's one group we want. We also want all the people who are between, was it 22 and 39? Yeah, 22 and 39. So we also want the sum of those two. Okay, so that's everybody who either responded or is between 22 and 39. And then we need to divide that by the total. So the total, sum again of all of them. All right. So the ones we want over the total is 0.8979, whatever. So it's pretty straightforward, ain't it? You like that, Taylor?
I do.
Okay. So we're on to 8, 9.
You just divided the total number by that 1100?
The other way around. I divided the ones we wanted, which, I mean, all the responded plus the 22 to 39s added to 1100. So I divide that by the total, which was the 1225 or whatever. And which one thing, I mean, to kind of double check, make sure you divided right. I mean, your answer should be less than 1. If we had divided the 12 by the 11, we would have got 1 point something. So that kind of tells us, hey, we divided the right way. Okay, so it wants to know, are these dependent or independent? So I guess I should tell you what dependent and independent mean. Which we kind of talked about this last time. So we talked about you've got just straight up probability of A is like numbers of ways A happens over total outcomes, right? I mean, that's just regular probability. But we also talked about conditional probability, which was probability of A given B. This is number of ways A and B both happen over the ways B happens. So intuitively, the second guy is we know B happens, and we want to know, okay, if we have that information that B happens, what's the probability that A happens? So, like for example, I mean, this was a silly example, but it was the first thing I thought of the other day. Like, if you want to know the probability somebody is pregnant, I don't know what it is, but it's some number. But if you say, okay, what's the probability someone's pregnant given that they're male? What do you think the answer is? 0. Right? Okay. So that brings us to the idea of dependent and independent. So,
Aren't they like conditional probability?
if you absolutely must. Again, we actually talked about this the other day, so it's. I see. I see.
Okay, thanks.
All right. So that leads us to the idea of independent and dependent. So two events, A and B, are independent. And as always, I hit something and my pen quit writing. Let's try hitting yes. Maybe that'll. There we go. Are independent if the probability of A given B is the same as the probability of A. So intuitively what that says is like, hey, if I know B happens, it doesn't change a thing. It's like the probability of A happening is going to be the same whether B happens or not. So i.e. the probability A happens doesn't depend on B at all. And then, of course, otherwise, they're called dependent. Right. Okay. As far as examples, the main instance where we have independent things is where you do something over and over again under exactly the same conditions. So like if I draw cards from the deck, but I put all the cards back every time. So every time I'm pulling from the whole deck, then each draw is independent of each other. Right? Okay. So let's go back. All right, so you've got 221 coins, 6 are pennies. When one of the coins is selected, it's one of the 6 Indian pennies. When another one is randomly selected with replacement, so we're putting the first coin we already pulled out back in, and then pulling out another penny. So are those independent or dependent? Yeah, they're independent because, again, we're putting the first one we got back. So that means both times we're doing under the exact same conditions. So are independent because the occurrence of one does not affect the probability of the other. Okay. So, and then the probability they both occur, well, let me go back to a little notepad. So remember we said last time, okay, there we go. If you want the probability that two things both happen, well, you need to know that one of them happens, and then you need to know the probability that the other one happens given the second one. Okay. So for A and B to both happen, well, B has to happen. And I need to know what's the chance that A happens given that B happens, right? But if they're independent, it becomes a lot easier because this guy is just the same as the probability of A, because we said A doesn't depend on B at all. So this is just the probability of A times the probability of B. Right? So if I want the probability of 2 Indian pennies, well, the probability of the first one's an Indian penny is 6 in 221. The probability of the second one's an Indian penny is 6 in 221. So just multiply them together. Equals 6 over 221 squared. And 6 decimal places would be 737.